So we're going to start looking at a whole bunch of different types of series and basically all the different situations that we may encounter. But before we do that, I just want to take a moment to look at some properties of series. So specifically of convergent series. Okay. And a lot of these properties shouldn't be too surprising. They're basically just going to follow from regular old finite sums. But we do have to be careful that we're only applying these rules to convergent series. So let the series of from n equals 1 to infinity of a sub n and the series of n equals 1 to infinity of b sub n be convergent series. Okay. And sometimes you'll just see this written as like let n equals 1 to infinity of a sub n be less than infinity or something like that. Okay. Then we have the following properties here. Then the sum of n equals 1 to infinity of the sum of the terms of the sequence converges, and in particular, it's equal to the sum of the individual series. Okay. So we can do this no problem with finite series, of course. Like we can rearrange the terms as we please, but it's not a given that these things are going to hold once we're looking at an infinite number of terms. When we start dealing with infinity, things can get kind of weird. But in this case, it does not. Okay, it does hold. And I'm going to actually change this a little bit so we don't have to rewrite the whole thing again to plus and minus. Right, this is going to hold over sums and differences. Okay. Now it's important that they must be convergent series. Okay, so I'll give an example of why after I write down this other one. So now for any real number C, the series n equals 1 to infinity of C times a sub n converges. Okay, so that's pretty helpful. We can take our series and multiply by anything. And in particular, n equals 1 to infinity of C times a sub n is equal to C times the sum of n equals 1 to infinity of a sub n. Okay. So this is essentially the distributive property, but applied over an infinite series now. So we can take any constant in or out of the series, just like we could with integrals, right? So you'll see a lot of the same rules with these infinite series and with integrals because they're pretty closely related, right? So this is helpful because now we don't need to think about every little minute variation of a series. Like we can just think of the series of 1 over n. We don't have to think of the series of 2 over n and 3 over n and pi over n or e over n or whatever. We can just take the constants out and just worry about the core series. So why do these need to be convergent series? So let's give an example for why these must be convergent. Okay. So consider a sub n equals 1 over n and b sub n also equals 1 over n. Then the sum of n equals 1 to infinity of a sub n minus b sub n is equal to the sum from n equals 1 to infinity of 0, which is clearly going to be 0 because you can add 0 an infinite number of times and it's always going to be 0. Okay. But this is not equivalent to n equals 1 to infinity of a sub n minus n equals 1 to infinity of b sub n, which would be infinity minus infinity. Okay. That's an indeterminate form. We can't say what infinity minus infinity is. So we have to be careful about this, right? We have to, before we just go ahead and combine two series, we have to make sure that each individual series is convergent. Okay. So either we need to show it, or maybe it's a series we've already studied, or it's well known or whatever. Then, we could go ahead and use it, but we have to be absolutely sure. Okay. So just as some simple examples of how we could use this. So if we did n equals 1 to infinity of 3 over n times n plus 1, then this is equal to 3 times n equals 1 to infinity of 1 over n plus 1. So this is going to be 3 times 1, which is equal to 3. Okay, so just simple things like that. Sometimes it'll be easier to break up a series, or it'll be easier to put it back together. Like we've already kind of seen with integrals. Sometimes it's easier to break up the two integrals. It's important to note, just like with integrals, we can't necessarily multiply two convergent series. And, we'll look at that more later. Meaning we also can't divide or anything like that. So we are only getting the addition and the constant multiple.